everybody. Thanks for coming. Also, thank you to the organizers as well. Like, it's really great to be here in the university and to get this all going as well. I don't speak any Indonesian, so if you want to shit talk me, then just speak it in your own language and it'll be fine. So this is actually my 4th time here in Bali. I was here in November last year doing GraphQL Bali in Canggu. And then I've just come back and forth because it's a beautiful island and you have a wonderful home. So thank you for being so welcoming, everybody. As mentioned, I have a company called rconnect.tech, or you can call us Rocket Connect, and we connect people through open source. So we have a bunch of open source libraries, and we try and foster innovation through open source and also community meetups like this as well. So if you're interested in open source or speaking at meetups like this, then I'll be around afterwards and I'd love to come and speak to you. So as mentioned, I'm from these lands and I like tea. So if anybody wants to come and talk to me about tea, you can. Also, I love a bottle of water. I've actually, a few times here, I've asked for a bottle of water and I've had to put on an American accent. So like a bottle of water, and then it comes through a little bit easier. But it's the Queen's English, so it's proper English. So I do a lot of code. I have a company called Rocket Connect, so I do a lot of management, a lot of talking, a lot of traveling now. But prior to starting the company, I worked at some of these organizations. So I worked on the Prisma ORM. So anybody using Prisma at all? Okay, Prisma, cool. I'm sorry for the bad code I wrote, okay? And also GraphQL, so massive in the GraphQL ecosystem and organizer of about 5-6 GraphQL meetups, Singapore, Bangkok, Bangalore, London, Taipei. And as well as that, I worked at a company called Neo4j, which is a graph database. And I'm going to be diving a little bit deeper into Neo4j today as well. And finally, we have a bunch of products as well. So GraphQL Debugger is one of our products that I'll show you at the end of this talk. And you can find out more information on GitHub. So what's quite interesting is I bought this camera in Bali last month, and I started a YouTube channel. So I actually done 2, can I point with this thing? I've done 2 videos in Bali. So I just went to the butterfly parks and waterfalls, and then the other one I'd done some laundry. So if you're interested in finding out about my laundry, then go check out my YouTube channel. And this one was in India last month as well, so if you're interested in that, then check it out. Anyway, enough about me. Let's get started with the code stuff. So I'm going to be speaking about the graph database Neo4j and GraphQL. Who's heard of Neo4j before? No? Okay, 1, 2? Okay, 2. All right, great. So you're in good hands. Just out of curiosity, who's using a database at the moment? So you're all front-end engineers or?
No, I work with Neo4j with my last company.
You worked with Neo4j yourself? Nice.
I just, reviewing code.
Okay,
So,
reviewing Cypher, was it?
Like learning the code, because my senior, he created some Neo4j I think for mapping places into maps, like querying, searching, and yeah. So he told me check this one out. So
Nice.
I haven't implemented yet. So yeah.
Maps would be a perfect example of using Neo4j because it's like a graph, everything's connected, right?
Yeah.
So Neo4j is a database, and I am going to dig into it for those who don't have an idea what it is. But who's actually using a database like Postgres, MySQL, MongoDB? Anybody using? Okay, any familiar names? Anyone want to shout out what you're using over here? What was that? Sorry. SQL Server, I heard, or yeah. Okay, nice. So Neo4j is a little bit cooler than SQL Server, so I'm going to show you how to get started. Then I'm going to show you how to interact with Neo4j with the driver using some Node.js code. Then we're going to go over a bit of GraphQL, and then we're going to mix them all together at the end. So graphs, Neo4j, it's a graph database. If you think about relational databases, you think about in rows, columns, and tables. in graph databases, you think of nodes and relationships. So here we have nodes, and these are the core principles in our database. So you can think of these nodes as somewhat like a table in a relational world. So here we have a movie table, and we have a people table as well. And what's really powerful about graphs is the relationships. So there's no point in just having nodes without any connection or relation between them. And so graphs have a fundamental principle inside them, and this is the relationship. And basically you can draw it on a whiteboard, and we'll get into this whiteboard model in a moment. And before I go further, let's have a look at our graph running. So Neo4j is a database, and you can run it locally for free. So this is Neo4j desktop, and it's basically like SQL Workbench, but for graph databases. So this is free to download, and I've got a database running, so I'll open that up. Here we go. And what I can basically do now is start writing some Cypher queries. And Cypher is basically the query language for Neo4j. So you can think of it like the SQL, but for Neo4j. So let's have a look and see what this language looks like. So I'm going to match all of the person, and I'm going to return all of the persons. There we go. We have all the people in our graph. And what you'll see actually is that each node, they have properties on the node. So this node has ID property, a born property, and a name property as well. So very similar concept to what you're used to in other databases as well. And of course, this is a graph. So we have movies in here as well. So let me return the movie, and then you'll see all the movies as well. But again, just querying for the nodes alone in the graph doesn't really make any sense. You might as well just use a NoSQL database and just have everything stored as JSON in there. The real power comes is when you start querying the relationships, and then you can sort of hop along the graph, and you can do like recommendations, for example. But I'll just show you what this graph kind of looks like. So I'm just going to match everything and return everything. And now what you see is that we have our graph with our relationships. Can I get rid of this? There we go. OK. So Neo4j desktop basically allows you to explore your graph through this visualization. So let's zoom in a little bit, and let's find, well, in fact, I'll tell you what I'll do. I'll say match the movie with the title of the matrix. And what I'm going to do is I'm going to use the Cypher query language to traverse these lines, which are the relationships in the graph, and find out all of the actors that acted in the matrix. So if I was to do this kind of query in a relational world, then I would probably have to have like a lookup table in the middle and do like a cross join to find out all of the actors that acted in that movie. But with Cypher and with graphs, the relationship is a core database principle. So I can just hop along and find all of the actors in that movie quite easily. So I'm basically going to draw what I'm asking for in Cypher, the query language. So I want to find out all of the actors that acted in the matrix, and I'm going to be pointing inwards to the movie because people act in movies. And I'm going to ask for all of the people. Just going to name that variable P, or it could be foobar, whatever. P person. And then return all of the P's. So now what that's gone is it's traversed that relationship for me, and it's gone and found all of the actors that act in the movie The Matrix. And so this is like a real primer, quick primer to cipher the query language. I'll just stop here. Does anybody have any questions? Okay, go ahead.
So it's interesting, but I'm curious about how actually the graphs database is stored in a real physical storage. Is it like if I have connections from one node to another node?
Mm-hmm.
Is it like having a pointer?
Yes.
From node one to another node, or is it like sequential?
It's a pointer.
It's a pointer.
Yes. So it's quite efficient to do this.
So is there any method if I have separate database?
Mm-hmm.
So pointing from one server to another server,
Mm-hmm.
is it like possible?
Not from the database. If you had two separate databases, then you would probably have to query that in your application layer and then join it in your application layer. Any other questions? Okay, cool. Okay. So as mentioned, nodes also have properties, and so this is where some of the value comes out of graphs as well, because basically you can annotate the nodes with JSON-like structures, key value pairs, to sort of bring your data to life. So that's enough about Neo4j and a primer into Neo4j. And at the end of this talk, I'm going to show you how to use Neo4j and GraphQL together. But first, I just wanted to give you a quick primer to what GraphQL is. So who's using GraphQL? 1, 2, 3. Who's heard of it? Okay. And then, so the rest of you have never heard of it before or never used it at all. Okay. So to understand GraphQL, we have to go back in time. We have to go back to Facebook Mobile 2011 when it looked like this. Does anybody remember how that looked like, Facebook, back in the day? Okay. And basically, what that was on that phone was the web view rendered on the phone. So what that meant is that mobile phone there was reading all the same data that the desktop client was reading. All the same images, all the same data, all the same HTML, CSS, images, everything. And these mobile phones back then in 2011 was, sub 2G network connectivity. So basically this was terrible for performance. These applications were running really badly. And they had to kind of think of a way to change Facebook to work both for the desktops and also for the mobiles. So what they started doing, as any engineer started doing, is they had their API talking to their database, and they had the posts and the dashboard URL and so on and so forth. And then 2011 came, and then they added mobile phones into the mix. And they wanted to use the same API, because why would you want to invent another API for all of your clients all the time? So then what they done is they adapted this API, and they added, a dashboard view for the iOS, and a dashboard view for the Android, or maybe a URL for the posts, but without the images instead, so that the mobile clients could read that data without destroying everybody's network. But quickly, they asked themselves this question, which is who's using REST correctly? This is not the right way we should be designing our APIs. We shouldn't be having a separate endpoint for every single client. This is just completely unmaintainable, untestable as well. And so they had to start thinking of a different problem, a different solution to this problem. And this is where GraphQL came about. So instead of thinking of their endpoints as rows, columns, and URLs, why not think of it as a graph and then put a query language on top of that graph so that the clients can read that data in any way they want to. And this is where GraphQL came about. So there's 3 points on the graphql.org website, and let's just dive a little bit deeper into those. So the first is describe your data. So basically, you have an API, and you want to describe what the API looks like. So you use the GraphQL schema definition language to define what the entities and models look like in your API. So we have a user, and it has a bunch of posts related to it. And we have a post as well. And then the next type that I'm going to introduce to you is called the query type. And this query type is basically saying that our API has two functions, one called users, one called posts. And if you query them, you'll get an array of either the user type back or the post type back. And so you start your GraphQL API by defining these schema definitions. Then you back those functions, those queries, by resolvers. And these are basically any function, could be like a PHP function, a JavaScript function, a Golang function, whatever, that basically returns data in the shape that the schema is expecting. So here I've just given you like a contrived example that the users just fetches the users and returns them. Then there's another part to the query to GraphQL called the query language. So once you've defined your schema using the schema definition language, you then use the query part to query that data. So you can see here that I'm asking for the user's name and location. And what GraphQL will do is it will resolve that exactly for you. So if we backtrack to Facebook 2011, when they had to implement a separate API for the desktop and a separate API for the mobile phone, well, the clients can just change their query depending on what that specific device needs. So here, we're asking for the name, the user's name and location, and we're getting exactly that back. But we can expand our query because we defined in our schema. And we can say, actually, for the desktop, I also want to display the posts because I'm wired internet, there's more bandwidth on the desktop, and there's more real estate to display stuff. So the client can just change their query and then get exactly that data back. So what this meant for Facebook engineers is that they can just define one API while the clients can dictate exactly what sort of data they want to retrieve. Any questions? Go ahead.
So defining one API, so we just return all the value from the API, to create this structure, it's from the client, right? Not from the server.
So the server is still returning that data. So for example,
all data?
Here. So users database.users.find is going to return maybe a JSON array of users, but the runtime will look at the specific query and filter out the values that aren't needed.
So the runtime is for from the client, he filter all what they need to render it in the front end.
The filtering's happening on the back end, so that the data doesn't get sent over the wire when it's not needed to be sent over the wire.
So it is a separate surface?
Yes. It's you would run your GraphQL API like the same way you would run your Express API or something.
You should create two surfaces, or you can create it in one?
You can create it in one.
Okay.
I'm going to show you as well. Yeah. Any other questions? Anything that doesn't make sense? Okay, cool. So before we get on to Neo4j and GraphQL, I wanted to show you how a GraphQL API looks sort of with some basic code. So here we have. Okay, so we've got 44 lines of Node.js code. I hope this is not too confusing for you guys, just let me know. So basically, with a GraphQL API, you start with type definitions, as mentioned. So here we basically have a very simple API. It has one function on it that you can call, called movies, and it returns a list of that movie type. Then you define those resolvers to back that query. So here I'm saying that there's a movie function on my API, and this, just for the demonstration purposes, hard-coded returns a JSON array of movies. And then down the bottom of this file, we just have some like boilerplate code to basically set up the API and get it started, pretty much like Express or anything like that. And this is pretty much boilerplate. You can copy and paste this from any documentation. So what I'll do is I'll start this server. So node resolvers. And so because GraphQL APIs are strongly typed, you have a bunch of developer tools available for you, because all the developer tools basically look at the schema and then give you a bunch of tooling based off of that. So this tool here is called Apollo Studio, and it's a free open source tool that basically allows you to interact with your GraphQL API. A bit like Postman. Has anybody used Postman before? Okay, so this is pretty cool. So this is pretty much like Postman, but for your GraphQL API. So I can issue a query, and I can ask for the movies and the title of every movie, and then it's going to show me the result that was. And just for the people who use Postman, I think I have it installed. We'll try and see if it works with Postman as well, so you can see how to use with Postman. So basically, localhost 4000 GraphQL. Let me zoom in. And then in the body, dismiss. Just put that in there, send it, and then you'll see. So it's basically just a standard API like you're used to, but instead of calling particular endpoints, you hit the same endpoint every single time, and you give it the body, which is the GraphQL query instead. So everything goes over a post, and everything that is returned is also a 200 JSON. And just to show you, if I query something that doesn't exist in the schema like ABC, you'll see that I get a 200 response, 400 bad request, and the JSON, the errors in the response there. So because we have that schema, it's telling me ABC, the field ABC doesn't exist in the schema. So basically you have these like guardrails up when you're using a GraphQL API, because everything's based off the schema. So you kind of can't do something that you shouldn't be doing with the API. Okay. And just to show you, we have movies title and released. So if I'm a client that wants to see the release date of a movie, then all I have to do is just add released in, and then it's going to resolve that for me and return that over the wire. Okay. So we've gone over quite a few things so far. We've gone over Neo4j, Cypher the query language, GraphQL, and now we're going to bring it all full circle and show you the Neo4j GraphQL library. So I was one of the first contributors of this library, so you're in good hands, and you can find it github.com/Neo4j GraphQL. And basically, as Neo4j, a database company, they want to drive adoption of their database. And so they built the Neo4j GraphQL library as a way for front-end developers to use the power of their graph while using all the benefits of a GraphQL API. So you don't need to know Cypher, the query language. You don't need to understand graph database concepts. You just need to know a little bit of GraphQL to get started. Just wait a second. Thank you. Terima kasih. Cool. So, as I said, you can go and start them on GitHub. It's open source, which is cool, so you can check out all the code. So, Neo4j. Okay, so to get started with the Neo4j GraphQL library, you use the GraphQL schema definition language. But here you'll see that there's a couple more things that we've used. And we've used these annotations, the relationship annotations, which are actually called directives in GraphQL. And what we've done is we've said that our database has a movie node, and it also has a person node. And the properties of those are, title is a string, and name is also a string. But what we've also done is we've annotated a relationship, and we've said that, people act in movies, and we're using the GraphQL schema as our database schema. Then what we've done is we've constructed a driver. So this is just like connecting to my local host Neo4j, nothing fancy there. And the real magic happens on this line. So we've passed in those type definitions, to the Neo4j GraphQL engine, and then that's basically going to generate for us a fully functional API that we can read, write, aggregate, perform analytics on. Just from basically the only input we gave it was these definitions. So let's give it a start and see what we can do. So I'm going to say debug. I'm going to put debug on so we can see the generated queries that the library generates for us. Okay, where are we? Here we are. So I'll refresh this. Release doesn't exist, that's correct. So in Apollo Studio, you can, because there's a schema to your API, you can basically explore it, and you can use this UI, and you can see the queries that are available to you, or the mutations that are available to you as well. So you'll see that there's 6 queries available to us now. There's 6 mutations, which mutation is basically GraphQL's version of a write. And then there's a bunch of objects, scalars, inputs, and directives, and stuff like that, which I won't bore you too much with those. But what that basically means is that we can run our movies query, and what that's done is it's generated the graph database Cypher query language statement, and then it's gone and executed it against our database, and then returned the results through the GraphQL API. And you'll see in the debug log, let's get rid of this. In the debug log, we can find it. Oh, there it is. Here. You'll see that from that GraphQL query, it automatically generated for us the relevant Cypher statement, and then chucked that into the database, return the results through the GraphQL API for us. But there's more. So because we added this relationship in, and as I mentioned at the start, graphs aren't really anything without the relationships, we can now actually start using this and querying the relationships and get like a JSON structure back. So where is it gone? Here. So, I want to ask for the movies and the title in every single movie. But what about if I want to get all of the actors, so all of the movies and the title of every movie, and then all of the actors in those movies and the name? Well, it's as simple as just writing that query, and then it's going to resolve that for us. So I didn't have to do a join. I didn't have to write a database query at all. It's just going to resolve that for me and return it straight away. And you'll see the generated query probably looks something quite ugly. It definitely does because I wrote it. Wherever it is, here. So it's going to match the movie. And then it's done what's called a subquery in Cypher. It's traversed that relationship using the pattern matching that I showed you at the start of this talk. And then it's basically combined it into a JSON structure ready to be used in your front-end application. And there's more to this. This API has a lot of advanced features, and it has like filtering, all generated for us. So those who are familiar with Prisma, it has basically a one-to-one feature set of all of the Prisma API on top of your graph database. So, I can say, let me just turn this off. I can say where inline the title, and I have like all of these filtering stuff available to me generated. So, find me all the movies where the title contains matrix, and I believe there's like four matrix movies, and it will give us basically all of those movies back. So that's it for Neo4j GraphQL. Just a quick primer. Takes about 40 lines of code to get started. Does anybody have any questions? Go ahead.
First of all, I would like to apologize if my English is bad.
It's fine.
Then I have some question for you, Mr. Dan. First of all, I would like to ask about what are common strategies for handling authentication and authorization in GraphQL APIs. Then the second one is, how does GraphQL mitigate issues related to overfetching and underfetching of data compared to REST? I have two questions because this is the first time I heard about GraphQL using as a service.
Sure. So to your first question, it was about authorization.
Yes, because
Right.
What I saw before, your code is, I don't saw any, how could I implement an authentication for my data?
Mm-hmm.
And
Sure.
then this, I ask you.
Sure, I'll show you. So there's two ways to handle authentication on top of the GraphQL API. One is called the context. So if I go to the code and I look at our Apollo server, there's a function here in the boilerplate of the server called context, and it's just returning an object. So let me just turn that.
Sorry, Dad, are you finished with the presentation?
No, we've got some questions.
Okay.
Yeah.
Sure. Go on. Continue.
So this context function gets called every single time a request comes into the API. And that log that I'm doing there is the HTTP request coming in. So you can basically get like request.headers.auth. So basically you can like use logic against that auth value. Like, I don't know, if, I'm just going to do pseudocode here, but like, if not throat, right, like that. So now if you send a request to your GraphQL API without the authorization header, it's going to not resolve that data for you. Does that answer your question?
Yes.
Okay. And another way you can also do authorization in GraphQL, which is a bit more complex, is you can use these directives. So there's actually one called auth, and you can say like, required rec.headers.auth token or something like that, and then only somebody with that token can access the title property on a movie. Does that answer your auth question?
That's all I want.
Okay, and you had a second question.
For the second question, I would like to ask about how does GraphQL mitigate issues related to overfetching and underfetching of data compared to REST? Maybe just sometime I saw about the tax overflow. They say about overfetching, so I would like to ask about that.
Sure. So with a REST API, if you had like a generic posts or we'll do movies, right? /movies, it returns a JSON structure, a JSON list of movies. There's no filtering going on there whatsoever. Even if you only want the title of every movie, you're still going to get back the release, the actors. But because we have the power of the query language, which I demonstrated here, so we want the name and location. It only returns the name and location. but then if we want more data, then we just include that in our query, and then it will give us back the extra data for us.
And the last one, I would like to say thanks because Neo 4 is free to use.
Yes.
Without any credit card.
Yeah, it's all free to use. GraphQL's MIT on GitHub, so
Thanks
yeah,
for that.
no problem.
That's all from me then.
Any questions? Okay. So as I said, my company is called rconnect, and you can find us at rconnect.tech. We have a bunch of open source libraries and projects on our GitHub. GraphQL debugger, so if you want to debug your GraphQL API, then you can use GraphQL debugger. And we have GraphQL AI as well, so we're getting into the AI space. You can generate your GraphQL queries using AI, so go check them out. And thank you very much for listening, and I hope you enjoyed my talk.